Hello everyone. In this video we are going to talk about 555 timer IC in detail, its pin out, its working, its circuitry, and also we'll implement the circuit in TinkerCad and breadboard. So here you can see in the breadboard a timer IC and here is the one too. Now let's learn about its pin out. The first pin is ground, the second pin is trigger, third is out, and fourth is reset. The fifth is control, sixth is threshold, and seventh is discharge, and eighth is the power itself. The pin sequence is anti-clockwise, and it can be inserted into the breadboard like this. And now, so this is the circuit of 555 timer IC. Here we can see the voltage being applied and through a voltage divider, and the voltage at this point is 2/3 of VCC and voltage at this point is 1/3 of VCC. And here you can see trigger and threshold. This is a comparator. So first of all, let's learn what a comparator does. I'm drawing it here. A comparator simply compares the two voltages that's given at its two input terminals. So if positive voltage is greater, okay, let's give a positive voltage name V1 and negative voltage V2. So if V1 is greater than V2, then it outputs high. But if V2 is greater than V1, that is negative terminal voltage is greater than positive terminal voltage, then it outputs low. So now, back to our circuit. So threshold voltage must be greater than 2/3 of VCC in order for this comparator to output high. So these two are input to this flip-flop, which is SR flip-flop. We all know what is a flip-flop. Now let me give you a context of what is a flip-flop. A flip-flop is basically made up of a latch. Since you can see the NAND gate and the crisscross feedback is a latch, but the flip-flop is synchronous and is more advanced than latch, as the input or the changes in the input is only reflected in the output if the enable signal is given. If the enable is low, then we cannot see the changes in the output despite we have changed the input. So now let's understand the working of the SR flip-flop. So let us consider if we give 0 in S and 1 in R and enable is high, then at that point of time the output of the NAND gate will be 1 and the output of this 1 and 1 will be 0. When the output of 0 is inputted to the input of another NAND gate, then the output of the NAND gate will be 1. This one will go as a feedback to the upper NAND gate, and here will be 1 1. The NAND gate will again return 0. This 0 will go as a feedback to the lower NAND gate, and here will again have 1. And in this cycle, the output of 0 and 1 is retained. Now let's see how if enable is low, even the changes in the input will be unable to bring the changes in the output. Now let us change the output from 0 1 to 1 and 0. And when enable is low, the 0 0 will give a 1 here, and 1 and 0 will give a 1 here. So when the input to the latch is 1 1, the state of the output is retained and there is no changes in the output. But as soon as we change the enable to 1, then the magic happens. Then the change in input is reflected in the output. Just like 1 1 will give you 0 as the output of this NAND gate, and 1 0 will give you 1 as the output of this NAND gate. Now the 1 will await and the 0 will give here 1. And the 1 is taken as a feedback by this and it will give you 0. And in this way, it continues the output to be 1 and 0. Now, here a matter of the fact that you have to remember. When we give S as 1, we are receiving Q as 1. We are giving R as 0, we are receiving Q dash as 0. So now this is proportional. See the internal circuitry of 555 timer IC. Here we can see all the 8 pins in this diagram. So now let us first see the voltage is being applied, and it is in a voltage divider fashion, catering to the negative terminal of first comparator and to the positive terminal of the second comparator. Now we have threshold voltage here that will be supplied to the positive of the comparator, and trigger will supply to the negative of the comparator. The voltage at the positive of the second comparator will be 1/3 of VCC, and to the negative terminal of the first comparator will be 2/3 of VCC. And the output of the comparator will go to the flip-flop that we just gave a context of, and when S and R will generate a Q and Q bar as output, the output of Q bar is again inverted to get the output, while the same Q bar will go to discharge transistor here. Let's talk about the working of 555 timer IC in bistable mode. For bistable mode, we connect a resistor R1 to the reset button of the flip-flop, and then from the VCC we connect resistor R2 to the trigger. So now let's see the working. Let us suppose we do not connect the push button and we just let the current flow, and that the trigger is high, and when trigger is high it's low. For the initial stage, let's see, both the comparator output will be 0. Why? Because the threshold is always less than 2/3 of VCC and the trigger will be greater than 1/3 of VCC. That's why both the comparator output is 0, which is why the state of Q0 and Q-1 is there. When we enable the trigger or give trigger high, let's give trigger high. When trigger is high, the comparator output is 0 0, and here reset is also high. So reset is high and the trigger is reset is high and the trigger is also high. So in this scenario, the output is low, which is why we'll. And now let us reset the trigger to low, and when push button is enabled and trigger is low, the comparator output will be high. The first comparator output will be 0 as it is, because the threshold voltage is still less than 2/3 of VCC. And now this is our input. As I've already said and talked about it in the flip-flop, what will be the output for 0 and 1 in S and R? So Q output will be same as S, which is 1, and Q dash will be 0, which is the same as R. So now the output will be 1. The output is high. So now when trigger is low, the output will be high. And even after this, if the trigger is high after this, then also the output will be 0 0, and the comparator will give the output 0 0 to the input of the flip-flop, and the flip-flop will retain its stage when both the inputs are 0 0. So now this stage is retained until when? Until when the flip-flop is reset. For the flip-flop to reset, we'll have to connect it through push button to the ground when the ground is connected. So the output will keep on being high until the reset is pressed. And when the reset is pressed, let's say the reset is pressed here. Okay. So when reset is pressed or the reset is low, then after what happens is the output is again reset into its original state, which is 0 and 1. doesn't matter the trigger is high or low, and then the output will be low. In this way, the timing diagram of 555 bistable mode can be made. Let's see the monostable mode of timer IC. In timer IC, for monostable mode, we connect the VCC through resistor R2 to the trigger, and now here is a push button in case we need to ground the signal, and then we connect a resistor R2 and give the input to the discharge. Similarly, we'll take the threshold, and here is a capacitor. So now let's see. When the initial output of the flip-flop is 0 and 1, which means output is 0. So when Q bar is 1, the discharge capacitor input base will be high, and due to which the discharge transistor will be activated, and now it will start conducting, due to which the threshold voltage will be low. When the threshold voltage is low, the output of the comparator will be 0, and when the trigger is high, this second comparator will also give 0. So when this is 0 0, the output will be retained, which will be 0. Now let's see that in the timing diagram. The trigger is high. The capacitor has not been able to charge or discharge. The output is low. But when, and the capacitor is not charging, so let's give it a -2 in the lower half side. So now this is the initial condition, but if we give the trigger low, that is activate the push button and give it to the ground, and by that doing that we give the trigger low. When the trigger is lowered, we can see what we can see. We can see that the output of the comparator will be 1, and now when the output of the comparator is 1, the Q will be 1 and Q dash will be 0, which means the output will be high. So the output will be high when the trigger is lowered. So up to when the output is high, in order to find out the durations for the output is high, we can see for the high output, the Q dash will be 0, which means the discharge transistor will remain short, and then the capacitor will charge through resistor R2. When the capacitor, the stage will be maintained until the capacitor is 2/3 of the VCC. Until then the output will be 0. The trigger will have the output 1 or 0, and the state will be maintained 0, and the state will be maintained. But as soon as the capacitor is charged to 2/3 of the voltage VCC, then what will happen? Then the output of the comparator will be 1, a sharp 1, and since the trigger is given a high, the comparator outputs 0, the lower comparator. The upper comparator outputs 1, because as soon as the capacitor is charged 2/3 of the voltage, the comparator will give 1. So in these conditions, we'll see a toggle which is 0 and 1, which is when the discharge transistor will again be activated and will block the threshold and again reset it to 0. So in this case, when does this happen? This will happen when the capacitor, how much time the capacitor will take to charge 2/3 of voltage. That will be the main deciding factor in for how much time the output will be displayed. Capacitor charged until, And then after, as soon as the trigger came, here the capacitor started to discharge, and with such a discharge the output was again dropped to 0. So this is the explanation for monostable mode of 555 timer IC. Look at the astable mode of 555 timer IC. It is also called as free running by multivibrator because the output is constantly fluctuating and acts as an oscillator. So let's see the circuitry for that. So now there are two resistors and a capacitor that is connected in this fashion, and the discharge transistor is connected to the in between R1 and R2. And here you notice the threshold and the trigger both are given the same voltage at this point of the capacitor, voltage of the capacitor. So now the oscillation truly depends on the base principle of charging and discharging of the capacitor. So now here the capacitor of voltage will be less than 1/3 of VCC because capacitor will take time to charge. So the output of the second comparator will be 1. And the output of the first comparator will be 0 because the same VCC is given to the threshold. And now, because of these combinations, we can get Q as 1 and Q dash as 0, which means the discharge transistor will remain short and the capacitor will rapidly charge through R1 and R2 until the capacitor is charged through 1/3 of VCC. Then the output of the comparator will be 0, which will do no good since the stage is maintained when the flip-flop input will be 0 and 0. So now let's see. When the capacitor is charged up to 1/3, the output will be low. The capacitor will charge from base to 1/3. The output will be high. We can see that. And when the capacitor charge will reach 2/3, then at this point this comparator will give 1 and the comparator will give 0. So with these combinations we can see the output will be 0 and 1, which means the output will be low. This is when capacitor is charged to 2/3 of VCC. And then after, what happens? The discharge transistors becomes active, and then after the capacitor is discharged through the resistor R2, which means discharging. Until when is it discharged? It is discharged until the fact that it will reach 1/3 of VCC, because after 2/3 of VCC the output of this comparator will be 0 and the output of this comparator will stay 0, which will do no good. Once the capacitor is charged a little below 1/3, the comparator will give the output of 1 and which will reset our flip-flop, which means that as 0, 1 here and 0 here, then the output is again high and the capacitor will start charging through R1 and R2, which means that we'll have the graph like this and the input output will be in the same fashion. So in this way this circuit will generate an oscillator. I'm going to show you the implementation in TinkerCAD. Here is a simple circuit implementations. I have implemented the 555 timer IC's bistable mode, and now we'll start simulations. This is the power supply, this is the oscilloscope, and we have joined the components exactly in the fashion that we discussed earlier. So now let's run simulations, and you can see that both the LED are blinking at particular interval. It's because the output is a pulse, which is a square pulse, and that's why.